Hello, my name is Steph, and today we'll be going over functions. Now, functions it's a fun module, I'd say. And there's sort of a little cheat to it. With functions, you query two numbers, and it'll be plugged into a function in which you'll have to find.
This is the story of a man named Stanley.
Now, that function, there are 40-something functions, 41 functions, each of them being different. So as you can see, we have digital root of a plus b squared, blah blah blah, blah blah blah, blah blah blah. So, a is going to be the number on the left, or the number you query first. And b is going to be the number on the right, or the number you query second. To operate this mod, you, of course we get a right. To operate this mod, you press a number, and then you press comma to put on the left side, and then you type in a second number, and then you query, and then you press Q. You can do it with any number that's not 0. So if you try to do 0 and query it with something,
Please, Stanley, think about what you're doing.
Nor can you do the same number.
But there is no answer. How could there possibly be?
And as you can see, you'll get a result each time. Now, the cheat that I was mentioning with this is that there is a pair of numbers that whenever you query them, they will always give you a result that is unique to each function. Those numbers being 5 and 8478. So as you can see, we got the number 808. Now, the reason why I laughed at this at first, you might have heard me scoffed, is because there's a function that's just 808. And that function, well, no matter what you put into it, it will always give you 808. That's basically just saying y equals 808. So, what we do after that is, we go to the letter that's stated on the module, so in this case Z, and we go forward or backwards based on the condition that's stated. So it's asking if there is no ports, and if there were no ports, then we would go forward by 5. And going forward is just going down. However, we do have ports, so we're going to go backwards, and so we're going to go backwards by 1 since we do have ports. So it's the digits in A and B times 202. So there is 1, 2, 3, 4, 5 digits multiplied by 202 is 1010. If I did do that correctly. Yes. Now, I didn't expect to get 808, so I'll do a couple examples since I have a little setup. So let's do 5, 8, 4, 7, 8, query. Now we get 16951. And, 16951. And we have 21L984. So, let's see, let me just write this down real quick. L984. And then let's go into, let me go to this. I have concatenating set up here, a concatenating-like thing. So let me just hide this. So let's go through each one of the things. So we have digital root of a plus b squared. So a squared is going to be 25, and that along with 8478 squared, that's going to be, 8478 squared. That is 7187648. Now the digital root of this, if we got an answer of 16951, I should write this. No, Now, if you know what digital root is, then you already know that it's not this function, but let me just go over digital root real quick. it's when you add up each number until you get a single number. So this will be a 7. Actually, first we have to do the parentheses part first, so that's a plus b squared. Ooh, I didn't even show this. So that's a squared, so 5 squared, plus b squared, and that'll give us 7187659. And with digital root, you just add up until there's a single digit. And 9s are negligible, since they will always give you the other digit, except when it's just 9 by itself, which will give you 9. So this 9 we can just ignore. Same thing applies with zeros. 1 and 8 gives you 9, so that is negligible. 5 and 6, that will give you an 11, which will give you a 2. 7 plus 2 gives you a 9, so you can ignore that, and we end up with 7. However, this is not 7, we got 16951. So, it is not a squared plus b squared plus c squared. Oops. Where is the eraser? Oops. I'll just curve this up. Okay. Cool. I'll just cut this part out. Now the next thing on our next function is a times b with even positions removed. Well, even position digits removed. So whenever there's a comma, that means you do the comma is sort of like a parentheses, in where you do the thing before it first and then the thing after it. So we have a times b with even position digits removed. So, oops. We have 5. Oh god, that's a terrible 5. 5. It's hard writing with a mouse. 5 times 8, 4, 7, 8 equals 4, 2, 3, 9, 0. With the even positions removed, that would be this and this, so we get 4, 3, 0. That does not match this answer, so we go to the next one. The next one is 8 concatenated with number of odd digits. What concatenated means is you just put it's like the elementary school joke where it's like where the kids ask you like, what's 2 plus 2? And like you say 4, but they say 22. It's the logic within that, you just put the numbers together. So this is 8 concatenated with the number of odd digits, concatenated with the number of even digits. That's hard to say. So this is saying 8 concatenated with number of odd digits, so we have 5 and 8, 4, 7, 8. So it would be 5, then 7, and then that concatenated with 8, 4, and 8. And that would give you 8, 5, 7, 8, 4, 8. But that does not match our result, so let's move on. Let's see. Oops. So, next one is the digital root of a plus b. That since we already know that digital root's gonna be a single number, we can just skip that one. Now we have a plus b modulo 1000. And I'm pretty sure we all know how to add, and with my expert modulo tutorial, you should know how to modulo as well. And since it's modulo by 1000 and our number is above 1000, we know that it's not going to be the modulo by 1000. Now, a plus b squared. Now this one could be interesting. Oops. So it's basically 5 plus 8, sorry, dropped my calculator, plus 8, okay. 8, 4, 7, 8, and then you square that, so that would be 5 plus 8, 4, 7, 8 squared. That gives you 7, 1, 9, 6, 1, 2, 8, 9. And that obviously does not equal this, so it's not a plus b squared. Let's see. The highest digit, that one should be pretty obvious. It's the one that's just, it's basically 1, 2, 3, 4, 5, 6, 7, 8, 9. Which one of those is the highest? And if we were to use it out of 8, 4, 7, 8, and 5, it'd be 8. So we know it's not that. The number of different digits missing. So that one's a bit hard to understand. Well, it's a bit tricky, rather. Basically, what it means is you grab every number from 0 to 9, and with the 5 and 8, 4, 7, 8, it's basically saying which one of these is not within one of these. So it's saying that not 5, 8, 4, or 7. So if you were to do that one, you would get 1, 2, 3, 4, 5, 6. You'd get 6. Since there are 6 digits not within 5 or 8, 4, 7, 8. Now we have larger times 2 minus smaller. Let's see. So 8, 4, 7, 8 times 2 is 1, 6, 9, 5, 6. And that minus 5 would be 1. And would you know, would you look at that, they equal each other. So we know that it is that function, the larger times 2 minus smaller. So once we have that, we can now take a look at what we have. Well, actually, at our thing. So we have the letter of L, and yes. And if the battery count is even, I'm checking the bomb, it is even, so we use a true value, so we're going to go for it by 6. So 1, 2, 3, 4, 5, 6. The digital root of a minus b. Well, yeah. Of the absolute value of a minus b. So, let's see. So we have the absolute value of these two minus each other, and since it's absolute value, we just put the higher one first. So we have 9, 8, 4 minus 21, 21. So that's going to be 3, that's going to be 6, and that's going to be 9. And then we're going to take the digital root of that. So 9 is negligible, but since this equals 9, our answer is just going to be 9. So let's just take a look at that, and we get 9. So yeah, pretty simple. Since I don't want to cover all the functions because it is 41 functions, instead I'm just going to show you how the weird ones operate. So, well, specifically the weird, the special things that not everyone would know. So, the absolute value, also seen as this, so like this, just basically means that the positive value, or the value without the negative. So if x were to equal -9, in reality, the absolute value of x would equal just 9. You just get rid of the negative. function 30. Okay. Function 38 says that. Wait, was it 38? In order? No, sorry. Function 24 states for all digits in order. And when it means all digits in order, let's take the number 69, 420, 67, 89, 1. Basically, it states that we're going to put these numbers in ascending order without any duplicates. So since 0 is first, actually, we just ignore any zeros, because a 0 in front of anything is still the same thing. So this is negligible. So then we have a 1. Cross that out. We have no duplicate ones. Then we put down a 2. We have no 3, so we skip that. We have a 4. We don't have a 5. We have 2 6s, but we only write down 6 once. Then we have a 7, an 8, and then a 9. And that would be all digits in order. I'm basically just going off the index at the bottom. Well, the appendix, rather. So, all of this. I already explained concatenate. Cubed is just, you should know what a cube is. It's a number multiplied by itself 3 times. The digital root, I already explained it. Lunar addition is a bit weird. So, let's see. Let me swap over to this. So basically, instead of adding normally, you would just take the higher number. So, if we were to take the number 69, 420, 87, 11 versus 9, 8, 4, 7, 2, 5, 3, 9, 1. In order to do lunar addition, we just take the higher digit. So the higher one of these is just 1, the higher one is 9, the higher one is 7, higher one is 8, then 2, then 7, then 4, then 9, then 9. And that's lunar addition. That one's pretty simple. To modulo is just subtract the bigger number. No, subtract the smaller number from the bigger number until the bigger number is smaller than the smaller number. So if we were to take the number 69, and modulo it by let's say 5, we just subtract 5 repeatedly. So we have 64, then 59, then 54, then 49, then 44, then 39, then 35, no, 34, then 29, then 24, then 19, then 14, then 9, and then 4. And the module 69 module 5 would equal 4, since 4 is now less than 5. Everyone should know what square root is. It's basically the opposite of squaring a number, so 5 squared would be 5 times 5, which gives you 25. The square root of that is just the opposite, so 25 divided by some number will give you that number squared. And I think the last one that is weird is, let's see. Oh yes, the last one, which is weird, is the number dots in Morse code. So 1 is dot dash 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 dash, 2 is dot dot dash dash dash, 3 is dot 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 dash dash, 4 is dot 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 dot, and you get the idea. So function number, let's see. Function number 11 in particular states the number dots found in digits when using Morse code. So if we were to create 5, 8, 4, 7, 8 again, that'd be 5, 8, 4, 7, 8. There are 5 dots found in 5, 2 found in 8, 4 found in 4, 3 found in 7, and 2 found in 8. And all of those added up would be 7, 11, 14, would be 16. But I believe that's everything I have to cover for functions. If you enjoyed that, good job. If you have any questions, leave in the comments below. And Khan Academy says, get a job.